Mic check, mic check. Mic check, am I audible? Hello. Please comment in the chat box if I am audible. Yes, I am. Thank you, Apurva. Thank you very much. Alright, we'll be starting in a minute. Please hold on. Anyone who's hearing, please put a hello in the chat box, so I should be able to know who is there, right? So we can have a quick introduction. Thank you. Hello Karthik, hello Praveen, hello Counseling Psychology. Thank you for stopping by. Thank you so much. Okay, we have I think 3-4 people. Let's begin. Give me a second. Hello everyone, how's everybody doing? I hope everybody's alright. Yes? Everyone's all right? One second, please. All right. Thank you so much. Thank you so much for being there. It's nice to see everyone is all right. Yes. How is everybody today? Is everybody okay? Yes. Hello. Hello everyone. Yes. Hello Praveen Kumar. How are you doing? Yes. Now it's live. Am I audible? Am I audible? Just say audible. Type audible in the chat box. Yes, if I am audible. For anyone who is live right now, there will be a live button in the YouTube window. Yes, if it appears that it's the video is delayed, you can just tap on the live button and it will just switch to the current second, right? Hello Sudhakar, how are you doing? How are you doing? Thank you so much. Thank you so much, everyone. It's nice to see everyone so proactive on the lesson today, right? Okay. Just small. There's a few issues. I'm just sorting them out. Okay. Anyway, so as you can see, there's my name on the screen. I am Kshitij and I have a double MSc and bachelor's in physiotherapy. I have been teaching physics for quite some time now, a few years, yes, and I have experience in different kinds of institutes. Okay, so before we begin, right, I'll give a quick intro to this course. The name of this course is the Raah course, and why is this relevant today? So I'll be completing the full course of physics for competitive exams, primarily NEET. It will help JEE mains people as well, because theory wise there's not a lot of difference between the syllabus of JEE mains and NEET, right? So what we will be covering in this course, I will try to be as comprehensive as possible, but if I miss something, that's probably because it will hinder the course and delay the course a lot, because there's a lot of material to cover, right? So we will try to be comprehensive but concise at the same time. Yes, give me a chat in the thumbs up if you understand this. Thank you, Vanshika. Thank you so much. Thank you, Sudhakar. There is always some latency, so I request everyone to just click on the live button in the YouTube window, right, in the app, so that there's no delay, there's no latency, minimum latency, right? It's not possible to have no latency, but minimum latency is ideal, right? Thank you, Praveen. Thank you, Sudhakar. Okay, so considering today's lecture, we thank you, Karthik. Thank you so much. So talking about today's lecture, we'll be talking about basic mathematics. We'll be I will try to cover the basic mathematics required in physics in three videos, in three lectures, but keep in mind that this basic mathematics will not cover vectors. We will cover vectors after basic mathematics is covered, so please don't be confused if I don't cover vectors in this series of three lectures, right? Okay, so today we'll be basically starting with trigonometry. Where's my cursor? Right, so as you can see here, we have basic trigonometry, we have differentiation, and we have basic integration, right? So I'll be covering, sorry, one second, trigonometry in today's lecture. As you can see, it's highlighted with blue, right? Oh my god, give me a second. So the target is for the three lectures to be the first one, that is today, that's basic trigonometry. In the next one we'll probably be covering differentiation, in the subsequent one it will be basic integration. Basic because there's lots of material to be covered in calculus, right? And integration is even more vast, right? Therefore we'll be covering basic integration. Also we will be covering error analysis in basic mathematics. Most probably, if not, I will try to teach it in a different lecture so that you don't miss anything, right? All talking about basic mathematics, we'll also be covering binomial theorem. Most likely, if I don't, just remind me in a future lecture, right? Hi Raghav, how are you doing? Thank you so much. Thanks to see your excitement. Lovely to have you here, right? All right, let's move on. So when we talk about trigonometry, right, what is trigonometry? Trigonometry basically uses triangles, right? Triangles to have certain ratios, to basically help you calculate values for unknown, unknown quantities, unknown entities, right? It's vastly used in physics to cover components, right? What do you mean by components? We will cover that later. I'll just give you an idea, because we need to understand vectors before we move on to components, right? So what will if I suppose everyone knows basic graphs, right? If you know basic graphs, just say yes, I know graph in the chat. If no, then maybe we might have to cover this in another lecture, but okay, just say yes if you understand what I'm trying to say right here, that if you know how to read basic graphs, just XY, two-dimensional graphs, double coordinate geometry, right? Type yes in the chat if you do. If you don't, just type need a lecture. Yes. I can see that this part is not visible. Just give me a second. I'll probably have to move it here. Right. Okay, seems like everyone who is online understands basic graphs, right? So when we talk about basic graphs, right, we have these two lines known as the axis. We have the x-axis, we have the y-axis. Okay, now when we talk about representation, we have the x-axis value on the left and the y-axis value on the right, and at the cross, at the center, we have the origin. This is known as 0 0, right? So what did I say before? I just said that we have the x values on the left hand side. So what that means is just to the left of the comma, not to your left. So probably if someone is looking to your left, you are seeing nothing right now. So probably think about that. Okay. So on the right, we have the y-axis value, that's y, right? So on the right side of the comma we have y value, on the left side we have the 0 value, right? So when we talk about vectors, right, we have an x-axis value and a y-axis value. So what does trigonometry have to do with that? So when we have a vector, it will have both of these coordinates, right? X coordinate, an x coordinate and a y coordinate. When we will be having vectors, right, most probably in a question we will be having some magnitude or something, right? So we will have to divide that magnitude. For example, I have 5. So how do I know that the vector of that magnitude, right? What magnitude, what value it has on the x-axis and what value it has on the y-axis. That's why we need trigonometry in physics. Okay, if you understand that, please type in yes. Thank you. Say yes, I understand why we need trig. And please don't worry, we will be covering vector mathematics and using components separately. It is not a part of this particular lecture. We will just be covering basic trigonometry in this lecture. So once I will be will be covering vectors or maybe kinematics, right, then probably we'll talk about components. It's not decided yet, it will be decided later. My purpose of talking about this components thing, right, is just to basically give you an idea of why we use trigonometry. It will have other uses as well, because mathematics is a very integral part of physics. Physics supports mathematics and mathematics supports physics in real life. So that's why we need to cover basic mathematics. Okay, seems like everyone understands the purpose of trigonometry, right? So as you can see on the screen, we have a triangle which is colored, basically a triangle of yellow color. You can see certain letters, right? We have sine theta, cos theta, tan theta, right? Anyone has any idea about any of this? Just give me type in the chat, yes, I have some idea, or you can say, yes, I know everything, shut up. I will not shut up, but you can type that in. And you have no idea, that's all right, that's fine. We'll be covering that in this video. Raghav says no. Don't worry, Raghav, you're fine here, you're all right. We'll be covering how much trigonometry you need in physics. Same goes for you, Vanchika, don't worry. Yes. Seems like someone is saying shut up. That's all right. You can still watch the video, but if you don't, it's all right then as well. But please stay online. Just kidding, just kidding. You can leave. Okay. So when we talk about trigonometry, we have three main ratios, right? We have sine, we have cos, we have tan, right? What you need to understand right now is sine is what basically perpendicular by hypotenuse, cos is base by hypotenuse, and tan is perpendicular by base. Confusing, I understand, that's okay. Just focus on the screen, right? Okay, so you look at this triangle, right? You can see P here, you can see B here, you can see H here, right? P is perpendicular, B is base, and H is hypotenuse, right? Okay, what does perpendicular mean? Okay, we have this little symbol here. If you don't know what the symbol is, that's okay. We call this theta. It's called theta. It's used to represent a measurement of an angle. We will have other Greek letters that we'll be using to represent these angles, or maybe something else in the future. but right now we'll be using theta. Most probably we'll be using alpha as well, because sometimes that's used as well, right? Okay, so talking about base. Base is the side of the triangle upon which the angle rests. So as you can see here, this theta is resting on the base, right? The perpendicular is the angle that's opposite the angle, right? It's just opposite the angle. Why do we call it a perpendicular? We call it a perpendicular because this is a right angled triangle. You see this square shape here right in the middle of the triangle. This represents an angle of 90 degrees. That's what it means when you call it a right angled triangle, right? So the perpendicular is the side opposite the angle. In this case, the angle is theta. The angle can be here also. Triangle has three angles. Try an angle, right? Okay, so the side opposite the angle in question, that's the perpendicular in the right angle triangle. Now, someone might be wondering, this side is also attached to the angle, then why isn't it called the base? There's a very simple reason for that, because it's the longest side. The longest side in a right angle triangle is always called the hypotenuse. As simple as that. Nothing very complicated, right? So if you got all of that, just put in a thumbs up. No more yes, right? Just put in a thumbs up. If you didn't, put in a thumbs down so that I can differentiate it from before when you said no, you don't know, right? Two people have said given me a thumbs up. Thank you so much. I will have it in my, when I'll be thirsty, I'll drink the thumbs up. Okay, it seems like enough people have understood that. Okay, so when we talk about sine theta, it is always the ratio of the perpendicular to the hypotenuse, right? Sine theta, cos theta, and tan theta. These will be, very important all the time when you're studying physics. You cannot study physics without them, right? So sine theta is the perpendicular by the hypotenuse. Cos theta is the base by the hypotenuse, and tan theta is the perpendicular by the base. Also, tan theta you can also say is equal to sine theta by cos theta. Okay, you can also say that, right? Now there are three other ratios which you can see in this. I don't think you can see cot theta in the screen, or anyways I will write it. Okay, so cosec theta is short for cosecant, okay, and sec theta is short for secant. Okay, oh sorry, before I forget, cos is not just cos, it's called cosine. It's short for cosine, right? And sin, even that's short for, you guess what's it short for? You will get nothing, but you will get an idea. Type in if you know what's the full form for sine. No one knows? If you don't know, just type in no. That's okay as well. Okay, moving on. We can't wait for so long. So the full form for sine is just basically sine with an e. with sine with the E. S-I-N-E. Sine. So cosine is the partner of sine, who's tired of him apparently. And we have cosecant and we have secant, right? So these are three things. Tan is what? Tan is short for tangent. And cot, we have another ratio. It's not visible here. I'll write it on the top somewhere where it will be visible. Oh, apparently secant is also not visible. Let me write down secant as well. Secant is sec. All right. So we have another ratio. It's called cot theta. Right. It's short for cotangent. Right. Like we have a cosine, we have a cotangent. And like we have a secant, we have a cosecant. Okay. All of them are partners. They are opening up a business firm to spread education. Okay. So as you can see on the screen, cosec theta is the inverse of sine theta, and sec theta is the inverse of cos theta. These are the 6 basic ratios which we talk about when we use trigonometry. When we use trigonometry, we use these 6 ratios. Cot theta is just the inverse of tan theta. Let me just write that down here because it's not visible on the screen. Cot theta is equal to 1 by tan theta. Okay. So now we are done with this part. Let me just rub a bit. So we have some space to work with. We'll be covering this. I have not yet covered the 90 degrees portion. We'll be covering it soon. So please wait for a bit. I'll be asking you for questions as well. So please stay tuned. Right? Okay. Okay, moving on. We have these two triangles which you can notice right here. Okay. So as you can see, theta in this case is 37 degree and theta in this case is 53 degrees, right? So when we talk about sine 37, right? If you remember, what was sine theta? Sine theta was perpendicular by hypotenuse, right? So if you look here, you have the perpendicular, that's 3, right? And we have the hypotenuse, which is 5. Okay. So sine 37 automatically it becomes 3 by 5. Right? What about cos 37? We don't have a base. But can you have a base without the third side? You will not have a triangle if you don't have 3 sides, right? So how would you calculate that? A long time in the past, we had someone who messed up mathematics and our syllabuses. He was called Pythagoras. He had this theorem. The crux of it was the square of the perpendicular plus the square of the base is equal to the square of the hypotenuse. If you are wondering, will you be having to, calculate the value of the base? You don't have to. I'll just tell you right here so that you don't worry about it right now. We'll be doing questions later. Right now, we are studying, right? So we don't have the value for the base, but the value for the base is right here on the screen. So if you know about triangles, the sum of the 3 angles of a triangle, it's always 180 degree, right? one angle is 37, another is 90. So the third one is 53, right? Now, if you can see right here, if this is 53, this is 37, right? So this is 37, therefore this side is 3. So this side is 3, right? We can move this. So this side is 3, this side is 4, and this side is 5. This is 37, this is 90, this is 53. So similarly, this angle is also 53, and this side is also 4, right? So solve the mystery of the third side. Okay, so what will cos 37 be? If you look over here, you have cos theta is base by hypotenuse. Now we have the miraculous value of the base. So we have base by hypotenuse, base is 4, hypotenuse is 5, cos 37 becomes 4 by 5. Did you feel that? Did you get it? Yes? And now, you have two ways to calculate the value for tan. Comment in the chat if you know. Yes, Praveen Kumar, Pythagoras. Thank you. I'm sorry. I saw your message a bit late. What are the two ways we can use to calculate the value for tan 37? One is already on the screen, and the second one I've talked about a few seconds before. Let me just erase while you comment. Hi Raghav, yes. So you have this question, right? So basically, when we talk about these ratios, these sine and these cosines, right, you can represent almost any physical quantity. You need to keep in mind that these kind of represent motion, right? As I just mentioned some time back, maybe it was not understood clearly. You can represent almost any vector, and each vector will have components, right? And these components, they will be the sine and the cosine, right? So yes, you can represent almost any physical quantity with these ratios. Thank you so much for asking that question. Lovely question. Okay, my question was, how will you calculate the tangent, tan theta, tan 37? For this, the answer, one of the ways is on the screen. Please someone comment so that I can know that you are listening. Okay, there are two ways, at least two ways, that you can find the value for tan 37. People are asking questions and they are not answering mine. I don't like that. You're welcome, Raghav. So, hi Karthik. So okay, for your question, so many real world tasks, like measuring heights, distances, they involve using vectors, designing buildings, tracking satellites, and navigation, MRI imaging, analyzing waves, see. So it depends on the angle and side relationships. Without trigonometry, these, I don't think these could be measured, right? If anyone is wondering why I'm out of frame, it's just because I don't have a separate chat window open. I am a poor streamer. And therefore I have a mobile open next to me here that's just showing me your chat right here. See? Does no one know how to calculate the tan? We cannot move forward. Please answer the question. Please answer my question. I answered your questions. How will you calculate tan 37? Okay, moving on. No one is saying, they don't know the answer. So I will tell the answer. That's my job. I'm teaching you here. You are not listening and I'm not very happy about it. Okay, so talking about tan 37, so there are two ways. You already have the sine 37 and the cos 37, right? So you can divide these two values and you can get tan 37. What that becomes? That becomes 3 by 5, right? And that was one of the ways you can divide sine and cos. Chat is delayed quite a bit. I will request you guys to please click on the live button so that you see the latest feed. Okay? No, Anuvashish, the answer is not 3 by 4. Or is it? Comment in the chat if anyone can agree with their answer or disagree with their answer. I don't know. Do you know? Oh my god, if chat is saying it, it must be correct, right? It should be correct, right? Of course it's correct. Of course it's correct. What Anuvashish is saying, it is correct. Just because I'm writing something does not mean it is correct. You need to be aware of what I'm teaching. Yes, I'm so glad that everyone is listening to me right now. Oh my god, my teacher is stupid. It is not the answer. It's 3 by 4. Of course it's 3 by 4. And a big shout out to every one of you. Thank you so much for being active in class. That's what a teacher asks for, right? Okay. So we have these three values, right? Will these values always stay the same? So whenever in exam you are shown such a triangle, right? It's not necessary that these values will be 3, 4 or 5. Right? What they can also be. Comment in chat if you know the answer. If from 3, 4 and 5, other than this, if you have an angle 37, an angle 90 degree and the third angle is 53 degree, right? What possible sides can you have? What possible sides can you have? I'm waiting. Someone please play some background music, cool background music. I'm waiting. I can't sing. Why is the chat delayed so much? I don't understand. At least someone should be knowing it. It's not that difficult and it's not an unknown fact. Okay, so whenever we talk about trigonometry, each angle, any angle, it will have some sides, right? And yes, Anuvashist is right. It can have 6, 8 and 10. No, Raghav, it cannot be 5, 12 and 13. It can be 5, 12 and 13 if the angles are different. But if the angles are same, 5, 12 and 13 is not possible. So you need to see here, right? You have 3, 4 and 5, right? The value for these sides can be any value that is multiplied by this. So what does that mean? You can multiply it by 2, so you will get 6, 8 and 10. You can multiply it by half, you will get 1.5, you will get 2 and you will get 2.5. You can multiply it by 3, you will get 9, 12 and 15. Right? Not 5, 12 and 13, 9, 12 and 15. Okay? If that is understood, please put in comments a thumbs up. So if it wasn't obvious, we have the value for sine 37. The value for cosec 37 will be 5 by 3. The value for sec 37, it will be 5 by 4, and the value for cot 37 will be 4 by 3, right? Okay, now similarly, everyone says, gives a thumbs up. Thank you so much. Thank you so much, Sudhakar. Thank you so much, Anu. Okay, love the participation right here, right? Okay, so we got the values. Where is my cursor? Oh, it's right here. Sorry. So when we have these values, right? We have these values. Now, sine 53 is nothing but 4 by 5. Cos 53 is nothing but 3 by 5. And tan 53 is 4 by 3. Right? Can you notice a similarity in the values of 37 and 53? What we can see is sine 53 is equal to cos 37 and sine 37 is equal to cos 53. Right? Isn't it amazing? So there's a very good reason for that. We'll be covering it very soon in this video. Please stay tuned. Right? Okay. If that much is understood, just stay tuned. I'm not going to say that comment again and again, right? Okay. Now when we talk about these values, right? When we talk about these values, so we have a typical number of values we have when we talk about trigonometry, all right? So as I said before, we'll be three main ratios are very important: sine theta, cos theta and tan theta. This table is really important. You have to learn it. There's no other way about it. Okay, so we have 0 degree, we have 30 degree, we have 45 degree, we have 60 degree and we have 90 degree, right? These values will repeat, their sign will change all the time. Okay, typically in the exam. Other than this, we have already discussed 37 and 53. These values will be there. Some other values can be there, but the values between 0 and 90 will repeat. Okay, so we have something called radians right here. Okay, right here. So what does this mean? Radians are the SI unit to measure the value of an angle. Okay, so pi radians, it equals to 180 degrees. So 2 pi, sorry, 2 pi, 2 pi becomes 360 degrees. Pi by 2 becomes 90 degrees. Pi is 180, so you divide by 2 and you get 90 degrees. Pi by 3 becomes 60 degrees. Pi by 4 becomes 45 degrees. Similarly, we have pi by 6, that becomes 30 degrees, right? So why is it in radians? Look at this circle right here, right? So a full circle, hello Yash, how are you doing? How is everything? We have started quite a bit ago, but I think if you're joining in between, when the class is finished, you can rewind the video, you can watch it again. Hopefully it will cover most of your doubts. Okay, so we were talking about 2 pi, right? So 2 pi is the amount an angle opens when it becomes when it measures a circle, kind of, you know. So 360 degrees. So imagine you are right here at this position, right? So when you rotate 360 degrees about this point, you will complete a full circle. Similarly, if you complete 180 degrees, you will turn around, right? So when we talk about the circle and its relation to angles, if the angle is in radians, right, then the angle is equal to L by R. L is the arc that is, being covered by the angle, and R is the radius of the circle. You can also write L is equal to R theta. Okay, something to keep in mind. So far so good. Is everyone here with me? Is everyone able to listen? Is it audible? Give a thumbs up and we will move on. Thank you, Andu. Thank you so much. Okay, moving on. I hope all of this is clear. We'll move on to the next slide. So, unfortunately, you will have to remember all of these formulas. All of this. I feel sorry for you, but you have to remember these. Okay, yeah. Okay, moving on. So these are called identities. The 3 identities associated with trigonometry. You will have to absolutely learn these. There's no way around this. No way around this. No way. Okay, so I have written these down so you can copy it. Right, the others will be moving on to. I'll be waiting for 10 seconds. Relax, take it easy. Write it. Don't worry. I'm just joking. You cannot write these three in 10 seconds. Once you are finished writing these, just put down, I have written it, sir. Thank you. You don't need to cry, Sudhakar. It's alright. I know it's hard, but trust me, it's not even the tip of the iceberg. It's barely even an atom. Done? Done? Thank you so much. Thank you so much. Okay, let's move on. So, as you can see, we have double angle formulae and we have addition formulae. So, let me ask you a question. What is 1 plus 1? What is 1 plus 1? One plus 1 is 11 because I see Stranger Things a lot. What? The chat is smarter than me. They know the value of 1 plus 1. Oh my god, how will I teach them? Oh no, I have failed as a teacher. I know what 1 plus 1 is. It's 4. You don't know anything. Okay, so why did I ask you what 1 plus 1 is? Because these double angle formulae, they are derived from addition formulae, right? We'll see in just a second. Sine A plus B, okay? Sine A plus B. I want you to be here right now because it's very, very important. Sine A plus B is sine A cos B plus cos A sine B. So simple. So simple. Hi Rick, how are you doing? I know your real name, but I will not tell it. How are you doing? How are you doing, Rick? So sine A plus B is sine A cos B plus cos A sine B. Thank you for spamming the hearts. I love you too. Okay, so we have sine A plus B, that is sine A cos B plus cos A sine B. Therefore, if you notice, we have sine to theta. Sine to theta becomes sine theta cos theta plus cos theta sine theta, right? And what do we get then? What we get 2 sine theta cos theta. Okay. So, thank you, Rick. Thank you for joining in. So, sine A minus B is sine A cos B minus cos A sine B. So difficult. 2 rupees difficulty. This difficulty is worth 2 rupees. What do you get in today's world in 2 rupees nowadays? Sin A plus B is sin A cos B plus cos A sin B. Sin A minus B is sin A cos B minus cos A sin B. Oh ho ho ho. Magic. Okay. Cos A plus B. What is cos A plus B? Cos A plus B is cos A cos B and what? Minus sin A sin B. So you see a pattern is appearing here, you know. It's kind of a pattern. So when you talk about sine, it will carry its partner with it. So sine is there with cos, sin A cos B, cos A sin B, and cos is selfish. It wants to subtract things and it wants to be with itself. That's why it's hanging out with cosine itself. So you have cos A with cos B, cos A cos B, and it's subtracting sine from itself. Ki, you know, get away from me, I don't like you. So cos A cos B minus sin A sin B. But you know, the beauty of mathematics and physics is you cannot run away from things for too long. So when you talk about cos A minus cos B, cos A minus B, sorry, not cos A minus cos B. When you talk about cos A minus B, you will get cos A cos B plus sin A sin B. No matter how selfish you are, you will have to add sine to yourself. Right? So now that we have the formula for cos A plus B, what will cos 2 theta become? Cos 2 theta, it becomes cos square theta minus sin square theta. Okay. Did I do something different? Did I do something magical? No and yes. Right? Are you with me so far? Alright, let's continue. So, tan A plus B. Tan A plus B is tan A plus tan B upon 1 minus tan A tan B. Right? Therefore, what do we get in tan 2 theta? Oh my god, tan 2 theta is not visible. Let me write it right here. Tan 2 theta. So we have, using the formula of tan A plus B, we have 2 tan theta 1 minus tan square theta. Okay. Tan A minus B, it becomes tan A minus tan B upon 1 plus tan A tan B. Right? Very simple, not so difficult, right? How is everyone doing so far? Is everyone okay? Everyone okay right here? Let me just rub a bit because I have to show you something very, very special before we move on to the next slide. Right. So I want you to look at this identity closely. So remember Pythagoras theorem, right? P square plus B square is equal to H square, right? If you divide this equation by H square, or if you move in Indian terms, move the H square to the other side, you will get P square by H square plus B square by H square is equal to 1, right? What does this look like? It looks like sine square theta, and this looks like cos square theta. So can we say that the identities of trigonometry, they are a derivative of Pythagoras theorem, right? Yes, he ruined our lives. He ruined our lives. That's what educators do. That's what I'm doing to you. I'm wasting your time and I'm ruining your lives. So, moving on. Okay, why have I written the same thing 3 times? We have a special case for cos 2 theta because it will give you a slight edge when you're solving, the papers, the NEET paper, the JEE paper. We have cos 2 theta. Can anyone remember what was the formula for cos 2 theta? Please put in the formula in chat. Quickly, we don't have a lot of time. Waiting. Please put the formula in the chat. Please. Oh my god, this latency, it's killing me. It's killing me. Has everyone fallen asleep? Or is my internet not working? I will not, at least I will try not to die in the stream. Thank you for caring about me. But please move on to the question. Please answer my question, I beg you. Please. Okay, we have one answer. You can be bad at math, but you will get better. I promise you. That's why I'm teaching you. We have one answer. If you agree with that answer, you can just say same answer as the person who has typed the answer. Is it okay? Is it not? I don't know. You can just say same answer if it's same. I don't know. You are the teacher, I am the student. See, you know the answer. Huh? You know the answer. But am I playing with you? That's the question. The answer can be anything, but the question is not whether the answer is correct. The question is, am I playing with you? Okay, too long. I can't wait for too long. So the answer is cos square theta minus sin square theta. Yes, Anu has answered correctly. You get 1 crore rupees. You have 1 KBC. Right. So we have cos square theta minus sine square theta. Now why do you have two different ones? So you can convert this into 2 cos square theta minus 1 and 1 minus 2 sine square theta. I have remembered all this. You will also have to remember it. But is it logical? Is it logical? If anyone knows how these three values are procured, obtained, just tell me. I'm dying to know. The answer you already know if you have been watching the lecture. We have just covered it. Please someone answer. We have just covered it. Just for future reference, if I do this, I am disappointed in you. There's always a kid in class who likes to raise his hand and say, sir, me. We love those kids. We love those kids. But I would like to hear the answer from someone else as well. These kids, they will get the ranks. They will get the prizes. They will get the rewards. They will win the International Physics Olympiad for us. Will they? Maybe. But what about others? Maybe she has answered correctly. Maybe she has not. Who knows? So moving on, if you look at this, right? If you look at this and you remember sine square theta plus cos square theta is equal to 1, right? So if you take the one here, right? If you take the one here, what will you get? You will get cos square theta minus 1 is equal to minus sine square theta. Now if you put this over here, you will get this, right? Similarly, if you take the cos square theta over there, and the one again over here, or you can do anything, basically you will get this. Or you can just put in, whatever you want. Life is self-adjusting. Physics adjusts to life. Everyone who got that, put in a thumbs up. In chat. It's not, thank you. It's not a hack. It's how the identity was gotten. So, when we talk about these special cases. Why have I told you these? Why have I told you these? Now the hack will come. Now the hack will come. So, when you get these identities, right, you can use these to calculate half angles. What does that mean? If you remember, we have this table right here, right? It has the values for 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. How will you get the value for angle 15 degree, right? So how do you do that? You use that table, right? But along with what? So you have cos 2 theta plus 1 by 2 is equal to cos square theta. So if you have the value for cos 30, you can get the value for cos 15. Similarly, 1 minus cos 2 theta by 2, 1 minus cos 2 theta by 2 will become sine square theta. So this is how you will get the value for sine 15, cos 15, and if you have the value for sine 15 and cos 15, you can get the value for tan 15 as well. This is the hack. This is the hack. That is why you need to remember these special cases. Now, where are these useful? Most definitely they will be useful in the JEE exam. NEET, maybe, maybe not. But JEE, definitely you will need these identities. When we will be doing questions, I will also tell you what values, these angles will have. So what, for example, what will sine 15 be, what will cos 15 be, just so you can remember. But right now, the goal is to remember the fundamental information, right? Moving on. Okay. So I told you one way right now how to calculate sine 15. I want you to find out what's the value of sine 15 another way. What will that way be? I don't want you to solve it right now. I will be solving it for you. Are you with me? Please put in yes sir if you are with me. I want to see yes sir, not yes, yes sir, because it will be different from the previous chat, right? Okay, so we will be using this table. So if you have written down that table, please open that page so that you will be able to solve this question with me. Okay, let's move back. Okay, so sine 15, you can write it as sine 45 minus sine 30. All right, sine 45 minus sine 30. We'll use this formula for sine A minus B, right? So that becomes sine A cos B minus cos A sine B. So sine 45 cos 30 minus cos 45 sine 30, right? So what's the value for sine 45? The value for sine 45 is 1 by root 2. Value for cos 30. What's the value for cos 30? We have root 3 by 2. Cos 45 is 1 by root 2 and sine 30 is 1 by 2. Okay, 1 by 2. Let's put in these values. 1 by root 2 into root 3 by 2 minus 1 by 2 root 2. Okay, so you have root 3 minus 1 upon 2 root 2. Okay, if you want, you can multiply by root 2 above and below, right? Or you can put in the arbitrary values for the square root of 3 and 2. So square root of 3, I hate this pen. So square root of 3 is approximately 1.732. Square root of 2 is approximately 1.414. You can put in these values over here and get the final answer, right? But for accuracy's sake, I'm just going to multiply by root 2 above and below, right? And give you the most accurate answer possible. So that will become root 3 minus 1 into root 2 upon 4. That's the value for sine 15. Did you get it? Yes? Did you get it? I'll just say one thing in Hindi. मजा आ रहा है कि नहीं? बता दो, मजा आ रहा है कि नहीं? Okay, let's solve tan 75. So, like sine 15, tan 75, you have tan 40 plus tan 30 plus 35, right? And what was the identity? The identity was tan 40 tan A plus tan B upon 1 minus, sorry, I messed up a little bit, just a little bit, I'm so sorry. Sorry, tan 45 plus tan 30. Okay, so tan 45 plus tan 30, 1 minus tan 45 tan 30, right? Tan 45 is 1, tan 30 is 1 by root 3, tan 45 again 1 and 1 by root 3. That's how you get the value for tan 75. Let's complete the math. So this becomes root 3 plus 1 upon root 3 minus 1 upon root 3. You divide, you finally get root 3 plus 1 upon root 3 minus 1. That's the value for tan 75. Put in the equal to and equal to here. So that was the second question, right? Now, right now I want you to take out your pens and copies. I will give you just one question, okay? I want you to calculate the value for sine 135. Put it in the comment box. Put the answer in the comment box. I will show you how to solve it. Hopefully I will not need to solve it for you, but I will show you how to solve it and I will show you the answer as well. looking for questions for you guys. Also, we'll be doing this one, cos 135 after this. Let's add a page here. Okay, so sine 135. No, you don't have to solve for cos 135, but yes, that's how you will get it. Both Anu and Raghav are correct. So sine 90 plus 45, you have sine 90 cos 45 plus sine 45 cos 90. Now cos 90 is our friend. You know why? Cos 90 is our friend because cos 90 is 0 and therefore this becomes 0. Sin 90 is 1. So sin 135 is equal to cos 45. Right? Amazing, isn't it? So the value is 1 by root 2. Simple. What about cos 135? So similarly, cos 135 becomes cos 90 plus 45. So cos 90 cos 45 minus sin 90 sin 45. This becomes 0. So cos 135 is nothing but negative of sin 45, that equals to minus 1 by root 2. Did everyone get the answer? Did everyone get the answer? Did everyone get the answer for these questions? Please let me know in the chat. Why is everyone sleeping? Raghav has asked a very interesting question. Raghav has asked a very interesting question. We will have to address that. Please, everyone else who is in the chat, is watching the stream, is watching the lecture, please let me know if you've gotten the answer. Karthik has gotten the answer, Vanshika has gotten the answer, Anu has gotten the answer. Praveen has gotten the answer. Okay, so Raghav's question is sine, cos, and tan are enough. What's this? Sine, cos, and tan are enough. Why do we need the other three? So see, all of these are important. Why? Because there are so many formulas, right? And these are there to just basically remember stuff, to make things easier, right? Make things easier so that there's no confusion, just convention and convenience. That's the answer. Okay, it's a good question, but the answer is not that good. Right? So moving on, we are almost there are, I think, 3-4 things left. No, we are left with a lot of stuff. Let's move a little bit faster. All right, let's move a little bit faster. Okay, so what's this weird device in front of us? A, S, T, and C, right? A, S, T, and C. See, that's what happens when you don't work properly. Oh my god, I hate this. This is T and this is C. Okay. T and C. Alright. ASTC. You need to remember this. I will let you know just now why, but you need to remember this. ASTC. 1, 2, 3, and 4. Okay. 1, 2, 3, and 4. Right. We just earlier we were discussing and we were talking about coordinates, right? So you can think of this as a graph. Okay, x and y, right? And here the x value, sorry, just give me a second. Just give me a second. So the x value, so when we talk about this point, right, this is 1, 0, okay, and this is 0 and 1. Okay, so you are seeing a circle which has radius 1, so we call it the unit circle. Okay, we have a unit circle. And why is this circle important? I will be teaching you right now. Okay. So this circle you can use to represent all sine, cos, and tan values. Okay, all sine, cos, and tan values. All sine, cos, and tan values. Sorry, just so both of these x and y, they represent either sine theta or they represent cos theta. Okay, values on x and values on y, right? So let's say let's call this cos theta and let's call this sin theta, right? So at an angle of 30 degree, right? At an angle of 30 degree, what is cos 30? Cos 30 is root 3 by 2 and sin theta is 1 by 2, right? You can almost see that in this figure, right? This is almost the half of this. So 1 by 2. This value is 1 by 2, right? 1 by 2. So this is sin theta, sin 30. And similarly, cos 30 is root 3 by 2. You can see this part is bigger and this is smaller, right? So root 3 by 2. That's why we have the unit circle. You can represent all of the values which were in the table on this unit circle, right? Is that understood? Right? Is that understood? Understood. That's the importance of this circle. And it's a unit circle, so to avoid unnecessary scaling, right? Okay. So what does ASTC mean? We have the first quadrant of this circle, the second quadrant, we have the third quadrant, and we have the fourth quadrant, right? We have the third quadrant and the fourth quadrant. Okay, so A stands for all, S stands for sine, T stands for tan, and C stands for cos, right? When you are in the first quadrant, all values sine, tan and cos will be positive. When you are in the second quadrant, only the sine values will be positive. Similarly, in the third quadrant, tan will be positive, and in the fourth, cos. Alright. So, we had a value of 30 degrees, right? Now, imagine I asked you to calculate the value for sine 120, right? Sine 120. You don't know that value. And if you had to calculate it without using the, addition formula, how will you do it? How would you do it? So, sine 120 can be written as sine 90 plus 30, right? And hold on, we are not going to use the addition formula. So, if you notice here, this angle is 30 degree. What would 90 degree be? 90 degree is this, right? So 90 degree, if 90 degree is this, 30 degrees is this, then 120 degree becomes theta dash, right? So this is 30 degrees from the vertical, this much. This value, right? This value over here, the value of the coordinates over here, they will tell you what sine 120 is. Okay, so if you remember sine 30, what was sine 30? Sine 30 was 1 by 2, right? From here, and cos 30 was root 3 by 2. And if you join this, right, sine 120 is still 1 by 2, but cos 120 it becomes minus root 3 by 2, right? So this is one way of using the unit circle, but I'll tell you a quicker way. So sine 90 plus 30, what you have to do over here is basically add the angle, right? So you have sine 90 here, right? So from sine 30 you add 90 and you again get sine 30, but as you have added 90, when you add 90 you change from sine to cos. So 90 means change from sine to cos, or the other way around. So sine to cos or cos to sine. So when you are talking about sine 90 plus 30, you have changed from sine